2.3, adding and subtracting matrices. The first example says give the size of each matrix. That's kind of important. So size of a matrix is going to be rows by columns. And so one thing you might remember is rows before co's. Maybe you can. Maybe that'll be easy for you to remember. Rows before co's. All right. So when you look at the size of that first example, you count the number of rows. I see 1, 2, 3 rows, and the number of columns 1, 2. This is a 3 by 2 matrix. And so then the second example B, 1, 2, 3 rows, 1, 2, 3 columns. That's 3 by 3. That's it. That's all there is to it for size. Count the number of rows, count the number of columns. It's rows before co's. So we look at example C, 1 row and 1, 2, 3, 4, 5 columns. That's 1 by 5. And then example D, 1, 2, 3, 4 rows and only 1 column. So that would be 4 by 1. Which of the above examples is a square matrix? Okay, well, just common sense there. Which one do you think is a square? Example B, right? Example B, the 3 by 3, because the rows and the columns are the same. It's just like a square. A row matrix or a row vector, well, which one is just a row? Example C. And which one is a column matrix or column vector is the one that's just a column, and that's example D. Matrix equality. Two matrices are equal if they're the same size and corresponding elements are equal. So example 2 says state the conditions that must be present for the statement to be true. If the statement can't be true, tell why. So when you look at those two matrices right there, you have to ask yourself if they could possibly be equal, right? And so in order to be equal, they're going to have the same size. Well, do they have the same size? They're both 3 by 2, correct? They're both 3 by 2, so they could be equal. The only thing that we would have to determine there to be equal is if this is equal to 33. As long as y equals 33, those two matrices would be equal, right? That's it. Everything else is the same. Corresponding elements are equal, assuming that y is 33. What do you feel about the next one? These are not equal. They can't be equal. Why not? Right. They're not the same size. One of them is 2 by 1 and the other one is 3 by 1. They're not the same. They can't be equal. That's it. Example 3, find each sum if possible. Now you're going to get ahead of yourself and you're going to get rolling because you're like, I know how to do this. This is easy. But you're going to mess this one up if you go too fast. So notice you could say 3 plus 1 is 4 and 4 plus negative 2 is 2 and 5 plus 4 is 9. You could add those parts, but then at some point you're like, oh, wait a minute, what's going to happen with this 6? Because there should be another part there. All right. What do you think it's going to take for me to be able to add two matrices? I'm sorry, what? Attach zeros to the end. Well, yes, that's right. Or any number. They're going to have to be the same size. Okay. If I'm going to add two matrices, they're going to have to be the same size. These are not the same size. I've got a 2 by 4 trying to add with a 2 by 3. I'm missing something here. I would need a number there in order to be able to add these. This is not possible. The next example is possible, and all you have to do is add the corresponding parts. So 3 plus 1 is 4. That's the first element, okay? Now, how you can name that, if you look at the rows and say, well, I know there are 2 rows and 1, 2, 3 columns, all right? You would call that number 4 the 1, 1 element. Think about your first row and your first column. Your 1, 1 element is 4, all right? So we look at the next element. 4 plus negative 2 is 2. If I was naming that, that would be the 1, 2 element. So we continue. 5 plus 4 is 9, and 1 plus negative 2 is negative 1. 2 plus negative 4 is negative 2, and 3 plus 8 is 11. Did I do that right? Okay, that's it for matrix addition. I think subtraction is a little bit harder because sometimes we trip over the negatives. One of these 2 examples is not possible. Which one? The bottom one is not possible, right? You see that? The bottom one is not possible because they're not the same size. So the top one must be possible. Now, I think it's hard to just subtract, okay? What I would encourage you to do instead of subtract, remember what we did way back when you learned how to subtract negatives, you said add the opposite, or some teacher said same change opposite, or whatever. I would probably do that. Change this into an addition problem where you add the opposite, and I guarantee it'll be a little easier on your brain. Okay, so I'm going to go add the opposite of all of those. Now, you don't have to do it this way, but I just think it's easier and it'll lead to fewer mistakes, I suppose. So now I just changed it to an addition problem. I'm just going to add like I did on the previous example. 3 plus negative 1 is 2. 4 plus 2 is 6. 5 plus negative 4 is 1. 1 plus 2 is 3. 2 plus 4 is 6. 3 plus negative 8 is negative 5. So double check your answer. Double check my answer. Did I do that right? Did you do it right? All right.